Hello everybody, so welcome to motion numericals, right? So today we will be doing numericals in motion. Basically we will be covering very simple type of problems and we will be also covering some conceptual problems which will be in the later section of this lecture. So first of all, to do motion numericals we need to know just three formulas. We need to know just three formulas, and with using those three formulas, which we call as equations of motion, we can solve each and every problem with very ease, and that is what we are going to do today together, right? So we do it together. You will not watch cinema, you will work with me. That is what I prefer. Okay? We guys should work together to ace motion numericals. Without wasting any further time, let's dive into the equations of motion that we are going to use. So see, in motion we are going to use basically three equations. Number one equation is v is equal to u plus at. You need to know what this signifies. V signifies final velocity, u signifies initial velocity, and a signifies acceleration. V signifies final velocity, u signifies initial velocity, and a signifies acceleration. Everybody knows this, right? Next equation is v square is equal to u square plus 2as. What does v signify? Final velocity. U signifies initial velocity, a signifies acceleration, s signifies over here displacement. S signifies over here displacement. Please write down. S is displacement. U is initial velocity. V is final velocity. A is acceleration. A is acceleration. Clear? And there is another equation of motion, that is displacement is equal to ut plus half at square. Okay, displacement is equal to ut plus half at square. You need to remember this equation to solve the problems. There is importance of this equations needs to be derived also. So you need to do the derivation for the proof of these equations, which is very often asked in school level examination, and I think always, as always, I think derivation is important. Okay, so we go ahead. So this is our first problem which we have taken. What is it? A bullet initially moving with a velocity of 20 meter per second. Then what is 20 meter per second? You will say, sir, 20 meter per second is the initial velocity of the bullet. So we can write u is equal to 20 meter per second. Then what happens? The bullet strikes a target. Okay, there is a target for the bullet. So what we'll do is we'll draw this. This is the target. Now before hitting the target, bullet is over here, right? This is the shape of the bullet, and here the bullet is having a initial velocity of 20 meter per second. Okay, now what happens? Now this bullet penetrates into the target. It is said after penetrating distance 10 centimeter, then it comes to rest. That means finally the bullet is in rest position. Then what does rest position means? Rest position means that velocity is 0. So bullet will come to its rest position That means here velocity is 0. And what is this rest position? That is 10 centimeter into the target. So can I say V is equal to 0? You will say yes, you should say. And what is S? Here there is a displacement that is given. The displacement of the bullet is 10 centimeter. So that is 10 centimeter. So that means 10 by 100 meter. So this will be 0.1 meter. 0.1 meter. Now if you see what has been asked, it has been asked to find out retardation. But we have already studied that retardation is nothing but negative of acceleration. So basically we have to find out acceleration. Okay? So if we have to find out acceleration, then what do we know? We know U, we know V, we know S, and we need A. So U, V, S and A. Which equation has all these things? You will say, sir, equation number 2. So let us use equation number 2. V square is equal to U square plus 2S. What is V square? You will say 0. What is U square? 20 square, that means 400. Okay, 2 acceleration is not known and here it is 0.1. Now it is minus 400 is equal to 0.2 A. Then what is A? A is minus 400 by 0.2, that is 2000 meter per second square. 2000 meter per second square. Clear to everyone? And if you see, this is negative, this has come negative 2000 meter per second square. Then what will be retardation? So I'll write, therefore retardation is equal to 2000 meter per second square. Done. My first problem is done and we have done it with ease. So everybody at peace. Let us go for our next problem now. Okay. So this is our next problem. What does it say? It says the train travels with a speed of 60 km per hour. Okay, very good. From station A to station B. So I'll write down, this is suppose station A and this is station B. So from station A to station B, the speed is 60 km per hour. Okay, and then it comes back to station A again with 80 km per hour. Very good. It has been asked to find out average speed. Now what is average speed? Average speed is total distance by total time. Everybody knows this. So how will you find this total distance? I don't know what is the distance between A and B. So I'll take that as S. So average speed over here should be 2S, because once you go from A to B and again you come back. So you are traveling from here, you are going S and then you are again coming back another S. So it is 2S. Next is the time taken when the body is traveling or the train is traveling from A to B. How will you find the time taken? So see, when it goes from A to B, time is equal to distance by speed 60. And then when it comes back, then the time is, suppose this is T1, this is T2, then the time will be S by 80. So here it will be total time S by 60 plus S by 80. Everybody do with me. Please do not lose focus, because if you lose focus then it will be a problem. But if you can keep focus, physics will be very interesting for you. It is only matter of numerical problems. If we can keep our focus, we will be enjoying the subject. So focus rakh ke chalo. So this is 2s. Here if you see, I can take s by 10 common. Here then 1 by 6 plus 1 by 8. S and S gets cancelled out. This 10 will go up and become 20. Here it is 6 and 8 have an LCM of 24. I can take this at numerator. Do it in your pace. There is no hurry. Don't need to compete with me. Though everybody needs to do in their own pace. You are learning physics numericals maybe for the first time in your life. So please go at your own pace. Okay. So this will be 3 plus 2. So this will be 480. 3 plus 4 by 7. The answer will come 68.57 kilometer per hour. Answer will come 68.57 kilometer per hour. Okay. So this is average speed. Take your time. You can pause the video, bring the answer, then go forward. Don't need to go fast. No need. Next, average velocity. See, here the train has gone from A to B, then it has again come back to A. So ultimately initial and final position is A only. So displacement over here is 0. Displacement is 0. So as displacement is 0, average velocity, velocity is a vector quantity, average velocity will be 0. Okay, done. Excellent problem, good problem. Okay, these type of problems are very good and we know now how to solve them. Okay, so we go to the next problem now. So this is our next problem. How are we going to solve this? Here it is said a car travels a distance of 100 meter. One car is traveling a distance of 100 meter. So I will take S as 100 meter. Okay, with a constant acceleration. I don't know what is acceleration. Okay, no problem. With a constant acceleration which I don't know, and an average velocity of 20 meter per second. That is very good. Average velocity is 20 meter per second. So I will write V average is 20 meter per second. Good, very good. This is a constant acceleration system. It is, I don't know the value of acceleration, but I know that acceleration is constant. Okay. So if acceleration is constant, then we must know that average velocity or average speed can be written as initial plus final divided by 2 if the acceleration is constant. Okay, if the acceleration is constant, we can write average speed or average velocity is equal to u plus v by 2. Okay, so now we know what is v. V is, so v is equal to 25 meter per second. V is given. So u is not known, so I will write u plus 25 by 2 is equal to 20 over here. So this will be 40 is equal to u plus 25. So u will be 15. 40 minus 25, 15 meter per second. So my first answer is done. Initial velocity I have found out. The next portion is very easy. I can use v square is equal to u square plus 2as. V I know 25, so that means 625 square, and u is 15, that means 225, that is 15 square, plus 2as, so 2as, s is 100 meter. 625 minus 225 is equal to 400. is equal to 200 A. So that is, I can easily get A is equal to 2 meter per second square. See, first 2-3 problems we took some time, but first 2 problems. But when I am doing the third problem, it is becoming much more easy because we are already getting a feel of the motion and also the equations of motion. Okay, so I hope each and everyone is getting the point. Take your time, relax a bit and go on doing. इतना relax मत करो कि सो जाओ. Don't relax so much that you sleep at this point of time. That is not correct. You need to spend some time on physics, okay, and definitely it will give you satisfaction. That much I can say you. So we can go for next problem. So this is our next problem. This is a very beautiful problem and I would like to take a different approach to this problem. Okay, so what kind of approach? Let us first study the problem. A spacecraft is flying in a straight course with a velocity of 75 km per second. So the spacecraft is flying at 75 km per second. Just take it like that. So I can write down over here that the spacecraft is flying at 75 km per second. It fires its rocket motors. So it has some motors. It fires it. So whenever you fire some engine, any engine, suppose you fire a car engine, what happens? The car starts moving. Without firing the engine, the car do not start moving. When you fire the car engine, the car will start moving. Now let us understand this thing. The car was initially at rest, right? When you fire the engine, by the energy from the engine, the car starts moving. That means the car is having a velocity now. Previously car was at rest. That means velocity was 0. Now the velocity is increasing. So if the velocity is increasing, there will be some acceleration, correct? So there will be some acceleration if the motors are fired. So there is some acceleration over here, which I don't know. Okay, no problems. At the end of the time, oh, here there is a time given 6 seconds. So I need to note this. At the end of this time, that is after 6 seconds, what happens? The velocity becomes, final velocity becomes 120 km per second. Okay, very good. You have to find out the spacecraft's average acceleration. Don't get confused by this average acceleration term. Average acceleration at this point of time is equal to acceleration because we are considering only constant acceleration system. Okay, so here acceleration is not changing. So calculating average acceleration means final velocity minus initial velocity divided by total time. So I can easily calculate acceleration or average acceleration, doesn't matter. What does average acceleration means? Average acceleration means change in velocity, whatever is the change in velocity divided by time. So change in velocity is nothing but v minus final minus initial. Any change means final minus initial. You need to remember this. Any change, okay, anywhere if it is written as del x, so that means x2 minus x1, not x1 minus x2. So v minus u, that is final velocity minus initial velocity divided by t. Okay, clear? Okay, now what is v? 120 km per second. So 120 minus 75 divided by time is 6. So here it will be 45 by 6. So that is 7.5. Now what will be the unit? See here everywhere we have used unit of distance as kilometer and the unit of time as second. If you would have used unit over here also, then also it would have come the same thing, kilometer per second, and here another second. So kilometer per second square. So this is the average acceleration done. Next, the distance travelled by the spacecraft in first 10 seconds after the motor were started. So motor was started and for 6 seconds motor was running. Then after that motor was stopped, right? Correct? because here it is also said, if you see, the motors having been action for only 6 seconds. Okay, only 6 seconds motor is in action, after that motor is not in action. So here I am talking about the other approach, what you can go ahead. Here if I try to draw a graph between velocity and time. So initially the speed was 75, finally the speed was 120. In 6 seconds the speed went up to 120 in 6 seconds. Another 4 seconds it remains in same speed or same velocity, because there is no motor. So no motor means no acceleration, no motor means no acceleration. So here it is a constant velocity. So this is the total graph. Okay, so now it has been said, find out the total distance covered. Total distance covered, many of you might be thinking, sir, I can go for direct graphical method, I can calculate it directly from the graph itself by calculating area. Absolute spot on, you can go for that. So you can take that as an homework. So calculate the area under this graph, calculate the area under this graph to check whether you get the same answer or not. I'll go for the equation of motion method. So here there are two kinds of motion. Okay, so this part, the first type of motion I'll take as S1 and the second is S2. So total distance covered is S1 plus S2. In first part S1, it is a accelerated motion. So how will you calculate the distance of an accelerated motion? You will say, sir, I'll use ut plus half at square. Absolutely spot on. What is u? 75. What is time in this first part? 6 seconds. Half at square. What is acceleration? We have already calculated 7.5 into t square, that is 36, plus this is S1 done. S2 is not accelerated motion, there is no acceleration. So in S2 it is a uniform velocity or uniform speed. So when there is a uniform velocity and uniform speed, you can calculate distance by using a very simple formula, that is speed into time. What is the constant speed at this point? The constant speed is 120 km per second, and that has been in operation for 4 seconds, right? The last 4 seconds, correct? This part. This is 10 seconds. So 10 seconds minus 6 seconds will be 4 seconds. So 4 into 120. So if you calculate this total, then you will get 1065 km. Take your time, calculate, there is no hurry. This is a very beautiful problem, and you also solve this in graphical method. That is a part of your homework. Okay, so I hope you understood this problem. We can go to the next problem. Those who are facing problems in calculations, take your time, calculate, find out the answer, pause the video, then go ahead. Another very beautiful problem, but this one we shall solve in complete graphical method. This one the homework is reverse. Solve the same problem with equation of motion. I'll solve this with complete graphical method, and you guys are also going to solve it together with me in complete graphical method. This is for them specifically who face a little bit of problem in graphical method. I think this problem will handle all these issues. Okay, so here it is said the train starts from rest. Here it is said the train starts from rest and accelerates uniformly at a rate of 2 meter per second square for 10 seconds. Okay, so first I'll draw a graph. The train is starting from rest, so velocity is 0, and it accelerates at a rate of 2 meter per second square. Okay, accelerating for 10 seconds. Okay, very good. So this is my 10th second. Next, it maintains a constant speed. Very good. it maintains a constant speed. So I don't know this speed, right? So I'll write this as V. I don't know this speed. Constant speed for 200 second, that is for 200 second here this total time is 200 seconds. So here the time scale will be 210 second, right? 10 second plus 200 second is 210 second. Next it is said it is uniformly retarded and comes to rest in another 50 seconds. So this will be 260 second. Understood this one? Okay, now we are going to solve the problem. So now the motion is absolutely clear. In this graph, when you draw a graph, the types of motions become absolutely clear. This is the very much importance of graph. So graphs must be done as much as possible with respect to physics, because this helps you a lot when you do some difficult problems in physics, whether it's in motion or somewhere else, and also it helps you a lot in class 11th. If you want, you can ask many seniors at Swapnit's classes that what is the importance of graphs and why various faculties over here gives lot of stress on graphs. The reason they are going to say you, let it be not said by us, they will give you the correct reason for it. I think how much graphs are important. Okay guys, so let's go ahead. So see, maximum velocity reached, that means I have to find out this velocity. So how I am going to find out this velocity? See, here it is said acceleration. Now what is acceleration? Acceleration is slope of velocity time graph. This is 2 meter per second square. This will be equal to del V by T. Now here the time is 10 second, del V by del T basically. So change in time over here is 10 second. And what is del V? V minus 0, right? Final velocity is V minus 0. So here I can easily get 2 into 10, that is 20 meter per second. Okay, see how when you get the graph, your concepts build up in a major way. There is a major shift in concept building when you get these graphs. Your maths becomes very much stronger when you can study the graphs, and we are going to do lot of graphical problems. So don't worry, you will be master of graphs. Yes, I am guaranteeing you will be master of graphs when you do some classes around, I think 1.5 years. I think you guys will be masters in graphs, right? Next, number 2, retardation in 50 seconds. Now you know that this V is 20. This is what? This is 0. So here also acceleration will be the slope, right? So if I take this as O A B C. Now if I take motion of BC, so acceleration in BC will be also del V by del T. What is del V in this part? The final velocity is C, 0. So 0 minus initial velocity is 20 divided by del T. Del T means the time change over here. What is it? 50 seconds. So this will come out to be 2 by 5 basically. So minus 0.4 meter per second square. So if anybody asks what will be the retardation in BC, retardation will be 0.4 meter per second square. Very good. What is the average velocity of the train? Oh my god, average velocity is super easy over here. Number 3, velocity average means displacement by time, but total displacement. How am I going to find out this total displacement? I am going to find out the area of this full trapezium. So what is the area of this full trapezium? I am going to find out half into sum of parallel side. Here it is, how much it is? 200. How much it is? 260. So 460 into height. Height is this much, that is 20, divided by total time, that is 260, 10. So This is 4600 by 260. So you need to calculate, you need to do some calculations over here, and I can ensure that you are going to get your answer. This will be 230 by 13. So the answer will be approximately whatever is it is given, 17.69 meter per second. So I would suggest you to do the calculation, do it in a slow pace, there is no hurry, and complete this problem. We have done this in graphical method, do this also in equation of motion method. Okay, clear to everybody? Very nice problem this was, right? Very nice problem, what I feel like, right? Now to the next problem, another very beautiful problem, and we are going to end our today's session with this problem. So it's an easy one. If it is beautiful, it need not to be tough, right? Every beautiful things are not complicated. So let's do this. There is a bus, okay, there is a bus. So there is a bus, I'll try to draw a bus. There is bus. So this bus is having some retardation, okay. So there is some initial velocity which I don't know. There is some retardation. Retardation means acceleration will be negative. So I'll write this minus 0.25 meter per second square, minus 0.25 meter per second square. Okay. B. Now what do we have to find out over here? We don't know what is V, so I'll write this like this one. The bus takes 20 seconds to stop. Oh, it will stop. So I know V. V is equal to 0. And the time is 20 seconds. I have to find out the initial velocity. So I'll use a very simple equation over here. V is equal to U plus AT. What is V? 0. V is 0. What is U? Not known. Plus AT. A is minus 0.25 and time is 20. So U will be 0.25 into 20. This one when comes to this side will be positive. So 25 into 20 is equal to 500. Point के बाद दो संख्या, so it will be 5 meter per second. ठीक है? I'm trying a bit of Hindi nowadays. अच्छा, distance traveled by bus. Distance, what is the distance? How I am going to find out the distance? Ut plus half AT square. So what is U? 5. What is time? 20 plus half into minus 0.25 into T square. What is T? Again 20 squared. So 20 into 20. 10. Here it is 100 minus, due to this minus. 0.25 into 10 is 2.5 into 20. 2.5 into 20 is 50. So here it will be 50 meter, and that will be our answer. Okay, so we have done around, I think, 6 problems. So I have chosen these 6 problems, which I think if done carefully in class, the rest of the problems in the exercise can be done by you. But however, if you guys face any problem in doing this other problems of your exercise, do let me know and I'll be very much obliged to help. After this, I'll be also sharing with you guys that a little bit of tougher problems on motion after you complete the exercise, right? So with that, thank you very much. Thank you everyone. Have a nice night. Okay.